So we're continuing now with part 4 with the Wi-Fi design, and we're going to talk about components of a Wi-Fi network. We're continuing with access points, and the access points has been a big topic. We want to talk about how we're going to power them and some other things. So, how do you power an access point? Well, your first option, which is the best option, is power over Ethernet or PoE. It's the most popular. If you can do it, do it. And the easy way is to plug your access point into a switch that has PoE, so that your switch is giving your access point data and power. And that's all you need. So you don't have to buy power over Ethernet injector. You don't have to hire an electrician to run a power outlet next to your AP, and then get permits and blah blah blah. Of course, sometimes your AP crashes and needs to be restarted. It's very easy. You can just go to your switch, unplug the data cable, and now you cut the power and plug it back in. Otherwise, if you have a power outlet and a warehouse ceiling, like I showed you earlier, you have to climb up to the ceiling and unplug the AP, and then that's not always very fun. So, what if you don't have a PoE switch? Then you install an injector, and the injector sits between the switch and the access point. So the injector takes your data cable from your switch and adds power to it, and now it's sending power and data to the switch. Of course, you can install a PoE anywhere you want, but probably in your server room, that's where you have a power outlet. Of course, if you have many APs, then you need many power injectors, so you'll be better off just buying a switch that has a PoE capability than buying 10 or 20 power injectors, which are way more expensive than a switch. So, well, about the same. So, yeah, this is basically it. On the left we have our switch with our Ethernet, and we add the injector, and now we have an injector with data, and now it's going to our AP or whatever it is. And they kind of look like this, a lot of them. I'm sure you've seen them. On the left we get data in, on the right we get data out and power out. And of course, actually, we can buy the entire strip, and these get either rack mounted or bolted to the wall or whatever. And now this one can power like 8 devices, so that's another option. And if you don't have a PoE switch and you don't have a PoE injector, then the worst option is to get an electrical outlet installed next to your access point, and then use the AC adapter and plug it in. And this is a terrible idea, because you need to hire an electrician to install the outlets next to access points, or you need to find the electrical outlets, and then that limits where you can install your access point. And of course, they need power adapters, so you need to buy a power adapter, and you need an access point that has capability of accepting a power adapter. And you can't restart the AP if it crashes. Like I said earlier, you have to go to the AP and unplug it, which can be a problem. And the electrical code typically says, hey, you can't install what we call flexible cord in a ceiling space, even a dropped ceiling. So that means that your power outlet has to be below the ceiling, not above, which means everybody's gonna see your power outlet and your big fat AC adapter stuck on your ceiling. So let's say you need to install an AP and you can't get data to the AP. So we've got a few options for you. Let's say you got a parking lot or some warehouse or something, and you simply can't run the cable, or it's too expensive or whatever. So what do you do? Well, first option is what we call wireless mesh. So we're going to show you exactly how this works in a minute, but if you can understand it like this, you have a whole bunch of APs everywhere, and they make a grid basically, and each AP sends and receives data with a nearby AP until they reach the main network. And so your traffic can bounce from one AP to the next until it gets to where it needs to go. And the APs usually have a proprietary algorithm that routes the data based on signal strength and how much load each AP has at the moment. So how does it work? Well, we've got our switch here. This is our main network. Might be like in the main building or whatever. And then we got a whole bunch of APs. Then let's say they're too far from our switch. So in this case, all our APs are connected and they can route traffic, but not a big deal. Now let's say here's our main network, and we've got all our APs and they're all connected to the main switch because they're all within 300 feet of each other. You got a whole bunch more APs out in the parking lot that are more than 300 feet away, and you got one of them says, hey, here's my signal. So it talks to a nearby AP, and the nearby AP talks to the switch. So everybody's happy. You know what I'm saying? So these two APs out here in the parking lot, they don't need to be connected directly to the switch because their signal reaches another AP who's connected to the switch. So that's great. And we can even add more APs even further away. And now these APs can talk, to a nearby AP, and that AP can send its signal that it received to another AP, and that talks to the switch. So now everybody's happy. And of course, this signal works in reverse as well. So, advantages. Yeah, it can provide Wi-Fi coverage in areas that can't accommodate your Ethernet cables, especially like wide open areas, outdoors. But of course, it does need a power supply. So those APs that don't have data cable, power is not an option over that non-existent cable. So you need to get a power outlet next to that AP. You got no power and no data, then what do? Well, we'll talk about that. But at the same time, you gotta think about, all this traffic is going along this mesh network, and so the data transfer can be slow because it has to go first AP and second AP and third AP, and each AP has to think about where the data is going to go next. So you've got a bandwidth restriction, and also latency could be very high before you get what you want. So let's say you can't install the data out in the yard and you can't install power outlets either. Well, you can install a solar panel next to each AP and power AP with solar power or a battery or whatever. So obviously you need to think about sun exposure and cost benefit analysis because solar panels are very expensive.